All right. Good morning, good afternoon, good evening, wherever you're at. I hope you're doing great. The purpose of this video is to just go over the homework from last night to make sure that you had all parts covered, as I'm away at a conference today. And so, taking a look at number 15, page 259, we had numbers 15 and 16 first. Number 15, what I want you guys to see as you look at this problem, first of all, it's a right angle, so we know the line is going to be perpendicular. And then it's also cutting this segment in half, and you guys know that to be bisector, so AB is the perpendicular bisector of that side. Now, if you notice the directions, is a median or altitude or neither? In this case, you can either put neither or a perpendicular bisector. Number 16, I see a segment that's coming from the vertex of an angle all the way down to the opposite side, and it's perpendicular to the opposite side. Now this would be the altitude of the triangle. How tall is that triangle going to be? It's going to be that length right there, whatever that length is. All right, so that would be 16. Numbers 19 to 21. The picture is pretty busy. In fact, your review will look kind of like this. Your test will not, but your test, remember, is going to be all pictures as far as the vocabulary is concerned. So as we look at this, number 19, identify the angle bisector. What I need to do here is I need to go around to each of the angles and look for one of the angles that's being cut in half. So as I look at angle D, it's not being cut in half. As I look at angle F, it's not being cut in half. As I look at angle B, oh, there it is. They're being cut in half. Those two angles are congruent. So BE would be the angle bisector there. Okay. Number 20, I'm looking for the median. Now remember, the definition of a median is a segment that comes from a vertex to the midpoint of the opposite side. And so as I start with angle D, the vertex here, the midpoint of the opposite side would not be point G. Okay, that is not the middle of FB. So I go to my next vertex, and if I look here, this is probably the one that's most confusing. A lot of kids might guess that this is a median because E does look like the same length as EF and DE, but do we know they're the same length? No, okay? Remember, we'd have congruency markings there if they were the same length. So if I go to point F, the vertex at F, and then I go to the opposite side, C, we see that point C is the midpoint of BD, those congruency marks right there. So number 20 would be FC. Number 21, the perpendicular bisector. I'm going to look for a right angle. So this line right here forms a right angle. But as we talked on the previous problem, FG is not equal to GB, so it's not bisecting it. While it is perpendicular, it's not bisecting it. So I go to the other right angle, and I see right here, this right here is not only a right angle, but it's also cutting that segment in half. And so as a result, AC is the perpendicular bisector of that side for number 21. Dropping down to numbers 30 and 31, those dreaded proofs. Thought we were done with proofs. Well, the thing is here, guys, we're going to continue to prove things all year long, okay? And so let's just kind of read through this and see if we can understand what's going on with this proof here. In number 30, it says complete the proof, this proof of theorem 5-6 by filling in the blanks. Lines L, M, and N are perpendicular bisectors of the sides of triangle ABC. X is the intersection of lines L and M. Line N contains point X, and XA is congruent, or is equal to XB, which is equal to XC. That's what we're trying to prove. So, proof. Since L is the perpendicular bisector of, now which line would L be the perpendicular bisector of? It's not, obviously not the perpendicular bisector of BC because it's not meeting at the middle or forming a right angle. So I'm going to say L is the perpendicular bisector of segment AB. We know that XA is equal to XB. We talked about that. The perpendicular bisector theorem says any point on that perpendicular bisector is the same distance from both endpoints A and B. Since M is the perpendicular bisector of, now let's look here, is M the perpendicular bisector of AC? I don't think so because this is definitely larger than 90 degrees and it's not the middle of AC. So I look down here. This looks like a 90-degree angle, and it looks like it's in the middle of BC. So M is going to be the perpendicular bisector of BC. Therefore, we would know that XB, okay, so this length here, is that going to be equal to, well, if it's the perpendicular bisector of BC, it's going to be equidistant from B as it is from C, so it's going to be XC right there. So using the transitive property, if XA equals XB and XB equals XC, then XA equals XB, which equals XC, okay? Bring those all together. Since XA equals XC, X is on a line N by the converse of the perpendicular bisector theorem, which says any point that is equidistant from the endpoints of a segment must lie on the perpendicular bisector, okay? All right, proof of theorem 5.7. If we look here, raise LM and N are bisectors of the angles of ABC. X is the intersection of rays LM and N, and then we have some perpendicular lines here. Remember we talked about how the shortest distance from a point to a line is a perpendicular line, so that's why they're putting those there. Ray N contains point X, and XD equals XE, which equals XF. So if we look here, X is on ray L, okay, all right. So we know XD equals XE, and I would just say this. If a point is on the angle bisector, then it is equidistant from the sides of the angle, okay? So those two lengths have to be the same. We know X is on ray M, so let's see here, X is on ray M, so this one right here. So I know XE would equal XF, and it would be by the same reason. If any point is on the angle bisector, then it is equidistant from the sides of the angle. You could also say the angle bisector theorem. How would we then know if XD equals XE and XD equals XF, that XD equals XE, which equals XF? I said it in the previous problem. That would be the transitive property, okay? And then from there, X is on line N, or ray N, by the converse of the angle bisector theorem, which again says if XF and XD are congruent, if it's the same distance from the sides of the angle, these sides right here, then that point must lie on the angle bisector, okay? So hopefully that was all understandable there with those. We're going to do the negation of each of these statements here for numbers 1 through 8. And number 8, we had some specific instructions I wanted you to do with that one. So number 1, write the negation. What would the complete opposite of two angles are congruent be? It would be two angles are not congruent. Number 2, you are not 16 years old. You could write down you are not 16 years old, but I think your English teachers would be a little upset with you. So we're going to say you are 16 years old because of the double negative there. The angle is not obtuse. So again, you could say the angle is not obtuse, but it makes much more sense to say the angle is obtuse. Number 4, the soccer game is on Friday. The opposite or the negation of that would be the soccer game is not on Friday. And number 5, the figure is a triangle. The opposite or the negation would be the figure is not a triangle. And then number 6, measure of angle A is less than 90. This is the key one here that a lot of people stumble on. What's the opposite of less than? It's greater than or equal to. It's got to include everything that would be opposite. So, numbers 7, 8, and 9. Number 7 and 8, we're just going to do the inverse and the contrapositive of each conditional. All right, so if you eat all your vegetables, then you will grow. The negation of that is going to be this. Okay, if you do not eat all of your vegetables, then you will not grow. Okay, and the contrapositive would be if you do not grow, then you do not or did not eat all of your vegetables. Okay. Number 8, if a figure is a square, then all of its angles are right angles. So A, the inverse, would be if a figure is not a square, then all of its angles are not right angles. Okay. Oh, this is the one that's got the special requirements here. Let me back up a second. The special situation for this one, we want the truth value of each statement. So the conditional, if a figure is a square, then all of its angles are right angles. That is true. Okay. The converse would be this: if all the angles of a figure are right angles, then it is a square. If all the angles of a figure are right angles, then it is a square. And that is false. You could have elongated one of the sides, forming a rectangle, okay? And therefore it's not a square. So the converse would be false. The inverse would be if a figure is not a square, then all of its angles are not right angles, okay? Well, if you draw a rectangle with one pair of sides longer than the other, you can see that it's not a square, but all of its angles are right angles. So again, that would be false, and that would be your counterexample. And then the last one, if all of the angles of a figure are not right angles, then the figure is not a square, and that is true. If you think of a shape that doesn't have all angles that are right angles, there's no way it can be a square, okay? So as a result, that was the homework there. Make sure you show the sub your work, and you can get started on your lesson.